Hi, for this session we will be covering an introduction to linear equations and graphs, and also how to use a table of values to draw a straight line. But let's just start right from the basics. So if you remember looking at the Cartesian plane, or it's also called a number plane, where we have a graph and we know that there's a vertical line and a horizontal line, and one of these lines is called the y-axis, the other one is called the x-axis. They cross over at the origin. Okay, and of course when drawing a graph you must use pencil and a ruler. And it's extremely important that when you start putting in your numbers, now if you don't have a grid paper, you get your ruler and you can do it every centimeter or every 2 centimeters depending on what your values are. But starting from 0, you must make sure you've got 1 centimeter, then 2, then 3, the same down here, 1, 2, 3, and the same for your x-axis. Never have a graph where your intervals, your scale, are not the same. For example, if you look at if I do my x-axis, imagine I had this. 1 was there. That means the next one has to have that same gap. 1, 2. But what if you did this, that, and then that, and you keep going? You can see how this is inaccurate. You must make sure your scale is accurate, and to do that, every gap or every interval in between each line, each unit, has to be exactly the same. That's why you must use a ruler, because a ruler has, for example, centimeters, and that could be your scale, every centimeter. And just quickly, we know that quadrant 1 is here, then quadrant 2, 3, and quadrant 4. Okay, now let's draw an accurate graph and we'll plot some points. Now I've done my best to draw 2 straight lines. It's a bit hard on the writing pad. We've got y and x, and make sure you're using pencil when doing this. We know they cross over at the origin. Now, and that's just 0. So now let's just put in some points. I've got grid paper at the back, so I can go 1 unit there, 2, but that'll be a bit squishy, so I'll do every 2 units, every 2 squares. So 1, and then 2, and then 3, and then 4, and then 5, and that looks like roughly a centimeter. And 1, 2, 3, 4. Okay, and I'll do the same for my y-axis. Now your y-axis can actually be different to your x-axis, and what I mean is, see the intervals of the x-axis were every second one. All right, for my y-axis I'll do every, just say, third one. So 1, 2, 3, 1, 2, 3, 1, 2, 3, and down here 1, 2, 3, 1, 2, 3, 1, 2, 3, and one more, 1, 2, 3. So you can see, oops, that's a mistake. The y and x axis doesn't have to be the same, but of course the interval for each one has to be. The gaps have to be the same for the y axis for itself and the same for the x axis. Now, I'll number them. So 1, 2, 3, 4, 5, and we know down this way it's -1, -2, -3, and so on. And your y axis is always positive on top. So +1, +2, +3, and down here -1, -2, -3, and so on. Okay, and I can squeeze in -4. And I'll do the same up here, -4. Okay, and 5. So now that we have an accurate graph, let's plot some points. And if you remember plotting points, we have x that comes first and then y. So if I have to plot the point, let's just say when x is +2 and y is -3, all we have to do is first go to our x-axis, because we know it's saying when x is 2, there's 2. And then what's y? Y is -3. So we go down following that line to -3, and that's the point, and we're done. Let's try another point. If I had to plot the point when x is, let's say, -3 and y is +3. So first step, go to x-axis. X is -3, there we are, and y is +3. Go up to the same level as +3, there it is, and that is the point where they meet. If it helps, you can actually draw a dotted line or a line, and you can rub this out or you can leave it depending on how many points you're plotting. And you can see that is the point where the 2 imaginary lines will cross over. Okay, sometimes you don't have grid paper, so it is more accurate to do this and use a ruler. Now, what happens if we have a point, just say, when x is 0 and y is 1? Now, the trick is, whenever you have a 0 as one of your points, you know straight away it will be on an axis. And because x is 0 and y is 1, so I'll go to my x-axis, there it is, and x is 0. So for x to be 0, it has to be right on the origin, but y isn't 0, y is positive 1. So I move up on the line, so I'm on my y-axis, and there's that point. Okay, when x is 0, as you can see, you go down to x is still 0, but y is positive 1. So the trick is, whenever you see a 0 in your points, you know straight away it will be either right on the y-axis or right on the x-axis, depending if x or y is 0. So if I had, for example, if x wasn't 0, if x was just say a 4 and y was 0, because I have a 0, I know I'll be right on the axis, but which one? It'll be the x-axis. Because for y to be 0, it has to be right on the origin, but we don't have 0, 0, x is positive 4. So move along the x-axis, and positive 4 is here, and that's where that point is. Y is still 0. Remember, 0 is at the origin, but x is positive 4. So these are the points where basically they're the hardest points you can plot, when either x is 0 or y is 0. And that's how we plot points. Now, our next step is to now identify what we mean by a linear equation. Now, if I write the word linear here, linear, we know, means in the word linear, there is this key word, which is line. And we know what a straight line is. A line can be that, can be this. Using a ruler, it will be a straight line. And so a linear equation is linked to a straight line. And if we have a linear equation and we actually draw it, so we'll be learning how to draw a straight line when given a linear equation, it'll always give us a straight line. So for example, I've put here a variety of linear equations, and these are all linear, and the reason is, if you have a look at the variables, with this first linear equation, you notice we have a y and we have an x. Now, if I asked you to solve this, could you solve it? No, because there are two unknown variables and you can't actually solve it because we don't know what x is and we don't know what y is. Unless we know what one of these are, we can't actually figure out what x is or what y is. Have a look at equation 2. Can you solve this one? Yes, you can. You only have one unknown variable. So x is the only number you don't know, and so you can solve it to make x by itself. But if you have a look at the first one, y is actually by itself, so y equals everything. But do we have a number? No, we don't, because we don't know what x is. Okay, so we're stuck. If we have a look at equation 3, can you solve it? There's a y and an x. No, you can't. And the same with equation 4. Oh, sorry, equation 4, you can actually solve it. Is there an x here? No, so you can make y by itself and figure out what y is. But when it comes to drawing straight lines, we're not actually aiming to solve the equation. We just want to draw a straight line. So for equation 1, we don't actually have to know what y is and what x is. Now, y and x, it links to your graph, the y-axis and the x-axis. That's why we have y. You'll start seeing y and x in linear equations. Sometimes you don't have to have a y and an x, like equation 2, you just have an x, and this is also going to give us a straight line. But most linear equations you'll be seeing from now on will have a y and an x. Now, to know if they're linear or not, there is basically one test you have to do, or one thing you have to check, and that is the highest power of any of the variables, in this case y and x, has to be a positive 1. We know there is an invisible 1 in front of the y and in front of the x. Same thing down here, invisible 1, and that's it. And because they all have a positive 1, all the powers of the variables, don't worry about the numbers. If we had, for example, 10 squared here, that's fine. It's only looking at the variables. Okay, if they're all positive 1, every one of these equations will give us a straight line. They will be different straight lines. They won't be exactly the same. Some may go this way, or some might be just vertical or horizontal. But because the powers of the variables is a positive 1, they will all give us straight lines. Now have a look at these equations. Are these linear equations? No, they're not. Because if you have a look, the highest power of y here is 1. But what's the highest power of 2? Of x? It's a 2. And because of this, this is not a linear equation. So we say it's non-linear. If we draw this, it will not give us a straight line. Have a look at equation 2. Power of y is a positive 1, but the power of x is a negative 1. So once again, if we draw this on a graph, it won't give us a straight line. So this is also non-linear. And with equation 3, the power of x here is 1, but what's the power of this x? It's a 3. So this is also nonlinear, and if we draw it, it will not give us a straight line. So now let's quickly have a look and see what happens when we change the powers and what kind of graphs we actually get. Now this here is just a free online graphics calculator that you can just type in Google and download. This one is called the meter calculator. All right, so here what we do is we basically put in an equation. So if I just move the screen, you can put in more than one equation, equation 1, equation 2. And when doing this, always have a y and an x, because y is referring to your y-axis and x is your x-axis. So for example, for this, I'll put in a linear equation, y equals x plus 2. I can just use the keyboard for this, but there are also buttons here we can use, and we'll use this later on. So there's my equation. And now if I graph this, let's see what the line will look like. And there it is. So that linear equation, okay, if we go back to the equation, y equals x plus 2, this is what, if we graph it, its straight line will look like this, okay? Let's try another equation. Oops, let's go out of that. Equation. So let's see what happens if I change, if I write maybe negative 2x plus 1. Let's see what happens. Is this still linear? Yes, it is. The power of y is 1, the power of x is 1. I've just changed the coefficients and numbers. So we graph this, and this straight line is going downwards, okay, but it's still a straight line. Now let's see what happens if we change the powers. I'll keep the same equation, but instead of having x to the power of 1, on my calculator there's a button here that's got x squared. There's also a power button here, so I can push power 2 or power whatever power you want, but I'll push the x squared button, just like your normal calculator. And you can see, now I'll delete one of the x's because the x came up as well. So we've got x to the power of 2. So now it's no longer to the power of 1. Let's see what the graph will look like. And if you have a look at this, this is what we call a parabola. It's no longer a straight line. It looks like a hill, basically. And this is what we call a parabola. And parabolas, their equations are called quadratic equations. Not linear equations, but quadratic. And that's something you do in year 9 and year 10, and also in BCE. So let's try another one. How about I make the y to the power of 2, so power 2, and I'll make the x to the power of 1. Let's see what happens. Have a look at this parabola. It's still a parabola, but you notice this parabola has gone on the side. That is because we made the y to the power of 2 and not the x. Okay, so that's also another cool feature. All right, what happens if we, let's start again. What happens if we have y equals, what about x to the power of maybe 3? So to the power of 3, let's graph this. Have a look at this. This is what we call a cubic graph or a cubic function. It sort of has like a squiggly bit in here and it curves up again. Okay? This is when we have powers that are to the power of 3. So you can see basically every time we change our power, the graph changes. So if we have power 1 for all our variables, it's a straight line. If not, it's something else. Let's try one more. Let's try to the power of -1 and let's see what we get. If you have a look at this graph, you notice it's sort of like two separate curves and it's sort of like a line that's, I guess, sort of joining them. This is called a hyperbola. You sort of learned this in year 11, but when you have a power to the -1 or x to the power of -1, this is what you'll get. Okay, so nothing like a straight line. So that's why it's very important to understand what we mean by a linear equation, and that means the powers of y and the powers of x have to be a positive one, and if we have that, then it'll always give us a straight line.